Everyone, very good morning one and all. Today I want to make a video on circuit analysis. In this video, we'll just try to understand how to apply various uh, problem solving techniques, means various methods to find the same quantity or the same current through a particular resistor. So it will be a long video. Please go through the video completely to get the benefit. So what I am trying to do is I will take one circuit, and for this circuit I will apply all the known methods. Like, first we will see how to apply mesh analysis. Next we will see how to apply nodal analysis. Later we will see how to apply some theorems like Thevenin's theorem. Fourth one is Norton's theorem. Fifth one is superposition theorem. So by applying all these techniques, we will see which method, by using which method we'll get the results easily. Okay, we'll get the same results, and we will check also. So whether we use mesh analysis or nodal analysis or Thevenin's theorem, Norton's as well as superposition theorem. Whatever is the technique that we use to find the current flowing through a particular resistor, we'll get the same result. But we will see what is the difference. What are the equations, means how complex it is to find the current flowing through a particular resistor in a particular method. All these things we can understand. We'll start with mesh analysis. I will take the same circuit for all the methods. Let me go to this next page. So the circuit given to us is a 8 volts battery or a 8 volts DC voltage source is connected like this. So this is 470 ohm resistor, and this is 100 ohm resistor. Next one is 1 kilo ohm, and next one another 1 kilo ohm resistor. For this 1 kilo ohm resistance, in parallel to it, a 2 amperes current source is connected. So this is the symbol for current source. You know it already. This is the symbol for voltage source, and this is the symbol for current source. So what we need to find in this circuit is, we can take any element as your load. So I am considering here this 100 ohm resistance as load. So what we need to do is we need to find the current flowing through this 100 ohm resistor. Now I'll start with mesh analysis to do this problem. Okay, so mesh analysis. See, in order to do the mesh analysis, we need to assume some loop currents or mesh currents. Related to that mesh currents, we need to apply KVL for each and every mesh, and then solve those equations. We'll get the current. We know this. Now I am assuming the mesh currents as I1. So this is the direction of the first loop current. This is the direction of second loop current I2, and this is the direction of third loop current I3. So I have three meshes here, 1, 2. So let me give the mesh numbering. So first mesh, second mesh, and third mesh or loops. In all, for all these three loops, these are the loop currents I1, I2, and I3. Based upon the direction of these currents, we need to apply KVL for each and every loop, and we can obtain the currents later after solving those currents. Now, how can we do this? In mesh analysis, there is a rule that the current for which you are writing the equation, means for first loop, if you are writing the equation, in this loop the current I1 should be dominating and the remaining currents should be lesser. Means you need to assume them as lesser compared to this current. When you are writing the equations for second loop, I2 must be assumed larger compared to I1 and I3. When you are writing the current for equation for the third loop, you need to assume I3 as greater than I1 and I2. Okay. Now let me keep the polarities of all the resistors according to the loop currents. When I am writing the equations for the first loop, so the polarities will be like this because the current is flowing like this. As the current is flowing like this, the polarities for this 470 ohm resistance are plus and minus here and plus and minus here. And this is already, we know this is plus and this is minus. Okay. Now let me write the equations for the equation for the first loop. See, when you can consider in any way, different authors or different textbooks will follow different techniques. Here I am following one technique, and that technique is when the current is moving from negative terminal to positive terminal, I will consider this as voltage rise. When the current is moving from positive terminal to negative terminal, I will consider it as voltage drop. Voltage rise I will represent with positive and voltage drop I will represent with negative. Okay, so that the sum of all the voltages in a loop is equal to 0. This is KVL, which is whose application is mesh analysis. Mesh analysis is the application of actually KVL, which is nothing but Kirchhoff's voltage law. The sum of voltages in a particular loop, it may be voltage rises or voltage drops, is equal to 0. This is called as KVL. Now I am applying that KVL to this loop. Now if you see the current I1, this is the imaginary current we have assumed. This current is moving from negative to positive, so it is a voltage rise. The voltage rise is considered as a voltage with positive sign. So I am considering with positive sign. So plus 8 volts, and here the current is moving from positive to negative, so it is considered as voltage drop. Now I am representing this with the voltage drop minus how can you obtain the voltage across a resistor? Voltage across a resistor is the product of the current flowing through that resistor and that resistance value. So it is minus I1 into 470. Similarly, through this resistor, which is common to first loop and second loop, there are two currents flowing. One current is I1 and another current is I2. Now if you observe, I1 is flowing from top to bottom. Similarly, I2 is flowing from bottom to top. So both are in opposite direction. Hence we can take negative sign. And as I told earlier, I1 must be dominating compared to I2 and I3 when I am writing the equation for the first loop. That's why I am taking minus because it is a drop. What is the net current or the resultant current flowing through 100 ohm resistor? It is the I1 minus I2 because both directions are opposite and I1 must be dominating compared to I2 and I3. So I am taking I1 minus I2 into 100 ohm. So this is the total voltage across this 100 ohm resistor and it is equal to 0. So from this what I can get is 470 I1 minus I1 into 100. So it is minus 570 I1. Similarly, minus into minus plus 100 into I2. When you send 8 to the RHS, you will get minus 8. So this is the first equation which we can obtain from loop 1. Similarly, second equation. Okay, so this is the equation which I obtained by applying KVL, which is Kirchhoff's voltage law, to loop 1. Next we will see applying KVL to loop 2. What is the equation that we can obtain? Applying KVL to loop 2. I am applying KVL to loop 2. When you apply KVL to loop 2, so I2 will be the dominating current according to this I2, we need to give the polarities across each and every passive elements. This is called as a passive sign convention. I hope you know about this. So now I am erasing this positive and this negative across this 100 ohm, which is common to first loop and second loop. Now I am giving polarities according to I2. So now current is entering here, so it is positive and it is negative. Similarly for this resistor, this is positive and this is negative. For this resistor, this is positive and this is negative because the current is flowing like this, okay, in clockwise direction. Now let me do the loop analysis for the second loop or applying KVL to loop 2. What is the current? The resultant current. So it is I2 minus I1. Okay, I2 minus I1 because I1 is moving from top to bottom. I2 is moving from bottom to top. So it is I2 minus I1 with the negative sign multiplied with 100. Okay. Next, through this 1 kilo ohm resistor, only single current is flowing and that current is I2. Okay. So it is minus I2 into 1 kilo ohm means 1000 ohms. And for this third resistor, we need to know, we need to write the equation like minus I2 minus I3 multiplied with 1000 is equal to 0. Now let me simplify this second equation. Minus I2 into 100 minus I2 into 1000 and minus I2 into 1000. 1000, 1000, 2000 and 100, 2100 with a negative sign. For I1 it is minus into minus plus 100 I1. So what you will get here? 100 I1 minus 2100 I2. Next minus into minus plus 1000 into I3 plus 1000 into I3 is equal to 0. This is the second equation. Now in the loop 3 there is a current source. When there is a current source in the loop, in any loop, we need to take that current source as the loop current. But if you observe, the loop current I have taken is opposite to the current source. That's why I can take that I3 directly as minus 2 amperes. Minus 2 amperes. Now substitute this I3 as minus 2 amperes here. What you will get? 100 I1 minus 2100 I2 plus 1000 into minus 2 is equal to 0. What is 1000 into minus 2? Minus 2000. When you send it to RHS, it becomes 2000. I am sending it to RHS so that equation 1 and equation 2 must be in the same format in order for solving. Minus 2100 I2. 1000 into 2 is minus 2000, and when you send it to RHS it becomes positive 2000. So this is the second equation. Okay, now we got two equations. So this is one equation and this is the second equation. Now solve these two equations using the calculator. Okay, so let me solve these two equations using the calculator. When you solve these two equations, you will get your answer as I1 is equal to minus 0.1543 amperes. So I am taking, after decimal I am taking up to 4 digits. I am rounding up to 4 digits. Next, I2 is equal to, let me write I2 value, minus 0.9597 amperes. Okay, so these are the two currents, and we know already I3 from the question itself. We can find the I3 value as minus 2 amperes. These are the loop currents, not the actual currents. All these are which currents? Loop currents. Loop currents are nothing but the imaginary currents which we have assumed. Okay, but in order to find the actual current, what is the actual current here? I. So that I is nothing but, if you see the diagram, so that I is nothing but I1 is flowing from top to bottom, I2 is flowing from bottom to top. I is in the same direction of I1. That's why I is equal to I1 minus I2. I is equal to I1 minus I2, because I is flowing like this. Okay, and I1 is flowing like this, and I2 is flowing like this. In order to know this current, we need to subtract I2 from I1. So I is equal to I1 minus I2. Now it is equal to, what is I1 value we got? Minus 0.1543 minus of minus 0.9597. It is equal to let me write at the top, because let me write at the top this value. I is equal to 0.9597 minus 0.1543. When you do this in the calculator, or you can do by performing hand calculations, 9597 minus 0.1543. What is the value? 0.8054. So 0.8054 is the answer. So I am considering this as 0.8 amperes. Okay. In this way we can find the current flowing through a particular resistor using mesh analysis. Now we will take the same circuit and do the nodal analysis. Okay, let me take let me select this diagram and cut it in the next page. Before that, let me erase loop currents. So I will take the same circuit, but now I will apply nodal analysis. Okay, let me take it. Before that, I need to select it. So I got almost the same circuit here. Okay, so let me bring it to the top. So this is actually 1 kilo ohm resistor. This is 1 kilo ohm resistor. Okay. Now what we need to apply? We need to apply nodal analysis. Okay, but we need to get the same that we will check here. So let me apply nodal analysis. Nodal analysis. In order to apply nodal analysis, first step is to identify what are the principal nodes we have, or junctions. Principal nodes or junctions are nothing but at the point where more than two elements are connected. These are called as principal nodes. Hence, in this circuit, we can consider this node where uh, the 470 ohm resistor, 100 ohm resistor and 1 kilo ohm resistance are connected. We can consider this as one principal node, and I am assuming the voltage at this principal node as V1. Okay. Similarly, I am assuming this as the second principal node because here 1 kilo ohm resistor, another 1 kilo ohm resistor, 2 ampere current source, all are connected. That's why I am considering this as another principal node. The voltage across this principal node is taken as V2. When you are applying nodal analysis, similar to mesh analysis, when you are applying nodal analysis, we need to assume the voltage at that particular node as highest voltage or highest potential, and the remaining all potentials as lowest potentials, so that all the currents as leaving currents, or you can consider all the currents as incoming currents. But in this case here, I am assuming all the currents as leaving currents, and this is the ground node on another principal node, and this is a reference node whose potential is assumed to be 0. Okay, so the potential of this reference node is assumed to be 0, and we need to find the potential of this node and this node with respect to this node. After finding these two potentials, we can find the current flowing through this 100 ohm easily. Now, applying nodal analysis is nothing but it is the application of KCL. What is KCL? Kirchhoff's current law. Kirchhoff's current law says that the sum of all the currents at a node is equal to 0. They may be entering currents or leaving currents. Another way of expressing KCL is the sum of incoming currents is equal to outgoing currents. Here, I am assuming all the currents as outgoing currents except a current source is connected to that node. That current must be considered according to its direction. Here, if you observe in the second node, the current is entering to the second node according to the current source. In that case, we need to take its actual direction. We cannot assume opposite or different direction. So that's why for this node, I am assuming all the currents as outgoing currents, means from higher potential to lower potential. Hence, I can take all the currents as leaving currents. So this one is one leaving current, this current is another leaving current, this current is another leaving current. Okay, because why it is leaving? Here these two are the potentials. When I am writing the equation for this node, we need to assume this potential greater than this potential, so that the current always flows from higher potential to lower potential. Hence I assume this current direction. Okay, let me apply KCL. For applying KCL, we need to apply KCL at which node? We need to apply at node 1. Okay, so this is the node 1 and this is the node 2. At node 1 I am applying KCL. So when you apply KCL, as all these currents are outgoing currents, the sum of all these currents must be equal to 0. Now how can you write the current, means the equation for the current flowing through this path, means through 170 ohms and through 8 volts voltage source and finally reaching the ground node. For this current, how can you write the equation? The equation is very simple. It is V1 minus 8 divided by, what is the resistance? 470 ohms resistance. And the current flowing through this path means it is V1 minus, what is this value? 0. So no need to write actually. So V1 minus 0 divided by, what is the resistance? 100 ohm resistance. Next, this current. What is this current? This potential is a higher potential and this potential is lower potential. So that I can write the current equation as V1 minus V2 divided by 1 kilo ohm, means 1000 ohms. Because according to according to Ohm's law, the current is nothing but the potential difference between the two ends of that resistor divided by the resistance value. In this way you can find the current. Hence we are getting the equations like this. T is equal to 0. Now bring all V1 terms to one side. So V1 taking as common, here you will get 1 by 470, 1 upon 100, 1 upon 1000. So 1 by 470 plus 1 upon 100 plus 1 upon 1000. And if you take V2, so it is minus V2, 1 upon 1000, okay, is equal to 0. Similarly, how can you simplify it? First simplify this value, 1 upon 470 plus 1 upon 100 plus 1 upon 1000. Let me simplify it with the calculator. So you need to be good at calculations so that you can get the result very easily. So for this the value is 0.0131. So I took up to 4 digits after decimal point, and it is minus V2 into 1 by 1000 is 0.001 is equal to 0. So this is the first equation. Next we will see the second equation. At this node we need to take the second equation. When you are writing the equation at this node, we need to assume all the outgoing currents, all the currents as outgoing currents except the current from the current source. So that I am erasing this current. Now what is the direction of current? So the direction of current will be like this, away from this node, one current, another current is like this. And what is this current? This is the current from the current source. That's why I am assuming it as incoming current, and its value is 2 amperes. Now it is the incoming current and these two are outgoing currents. So sum of incoming currents is equal to sum of outgoing currents according to KCL. So I am applying KCL to the second node, or node 2, applying KCL at node 2. We are applying KCL at node 2. When you apply KCL at node 2, you need to write the equation for this current. So it is V2 minus V1, because now we need to assume V2 as higher potential, V1 as lower potential. So V2 minus V1 by 1000, it is according to Ohm's law, the current value, plus V2 by 1000, 1 kilo ohm means 1000 ohms. And what is the incoming current? These two are outgoing currents and the incoming current is 2. So okay, so the outgoing current, sum of outgoing currents is equal to incoming current. Now we can take V1 terms to one side. So it is minus V1 into 1 by 1000 is 0.001 plus V2 into 1 by 1000 plus 1 by 1000. It will be 2 by 1000. 2 by 1000 is 0.002 is equal to 2. So this is the equation 2. Okay. Now what we need to do? We need to solve the equation 1. What is the equation 1? So this is the equation 1 in terms of V1 and V2. And this is the equation 2 in terms of V1 and V2. We need to solve these two equations to get the values of V1 and V2. Okay, so let me do with the help of a calculator here. So you need to do by using scientific calculator, you can solve these type of problems. Now we are solving the equations, two equations with the two unknown variables. Here I forgot one thing, which is sending 8 by 470 to another side. So when you send 8 by 470, let me erase this portion. So I am erasing here 0. 8 by 470 I am writing. So 8 by 470, 8 by 470, and here also you will get 8 by 470. Let me erase 0 here. I made a small mistake, means I have not observed the constant term, that's why I made a mistake. So 8 by 470. So the V1 which we will get is, let me check it, V1 value 0.0131, it is a minus 0.001, and it is 0.1017. Now you will get V1 value. So V1 is equal to 80.71 volts. V2 means the voltage at node 2 by applying the KCL or nodal analysis, 1040.35 volts. Okay. Now what we can do in order to know the current through this resistor? What is the equation for current through this resistor? I, just V1 minus 0 divided by 100 according to Ohm's law. Is it right or not? Let me do it. So current flowing through the resistor I, 100 ohms, is equal to V1 is the voltage at one end of the resistor, 0 is the voltage of another end. So the difference between the two voltages divided by resistance value. So it is 80.71 divided by 100. So what you will get here, 0.8071. Now finally I can write up to 2 decimals, so 0.80 amperes. So this is the current flowing through the resistor which we got by applying nodal analysis. By applying mesh analysis, what is the value of the current we got? So this is 0.80 amperes by applying mesh analysis, and by applying nodal analysis we got the same value of current. Okay, so which one is easy compared to mesh? Nodal is easy because here I need to solve only two equations, and getting the solution for the equation seems little bit easy. So nodal analysis is easy compared to mesh analysis in this particular case. Now we'll take the same circuit. So let me erase some of the things. Let me take the same circuit. That's it. Let me take the same circuit and paste it in the next page, because I need to apply Thevenin's theorem. I need to apply Thevenin's theorem. Let me bring it to the top. So I am taking the same circuit. Here 1 kilo ohm resistance is missing every time, no problem, and remaining all are same. Okay, 470, 100, 1 kilo ohm, and 8 volts, 2 amperes. Now let me apply Thevenin's theorem. How can we apply Thevenin's theorem? Thevenin's theorem is applied by opening these terminals. Okay, so let me open it and cut it. So this is the load resistance, right? That's why I am opening it and I am cutting it. So let me draw one more circuit. After opening, how the circuit looks like. Let me draw. In order to let me draw. So this is a 8 volts voltage source, and this is 470 ohms resistor. Here we need to open these terminals. Wherever we want to find the current, through whatever element we want to find the current, that element must be opened, because at that open circuit terminals we need to find Thevenin's voltage and Thevenin's resistance, which is VTH and RTH, and then apply Thevenin's theorem to find the actual current. Okay, so this is the actual circuit. By opening this element, means I have opened this element, and I am considering the remaining elements as it is 1 kilo ohm, 1 kilo ohm. I am opening here. Okay, now what we need to find is we need to find the voltage across this open circuited elements, and we'll call this voltage, I will call this voltage as VTH. VTH is nothing but open circuit voltage when all the sources are connected and the load is disconnected. How can I find the voltage across this open circuit terminals? I can find either the voltage across this node A and B. Okay, so in this way, or I can find the voltage across this 1 kilo ohm and this 1 kilo ohm and add. I will get the voltage across this. In order to do that, first I need to apply either mesh analysis or nodal analysis. Here I think applying mesh analysis is much easier compared to nodal analysis. Assume this voltage, the voltage at this node as V X, for example. Now apply nodal analysis. When you are applying nodal analysis, you need to assume all the currents as outgoing currents. So this is one outgoing current and this is another outgoing current, but this will be incoming current. So sum of all outgoing currents is equal to incoming current. This is KCL, and we are applying nodal analysis to find VTH. First we need to find the Vx, and from that we can find VTH easily. Okay. First find Vx. How can you find Vx? Applying nodal analysis, it is Vx minus 8, because these two are connected in series. As it is open circuited, these two are connected in series. So this voltage minus this voltage divided by sum of these two resistances, because 470 and 1 kilo ohm are in series. So if I want to get the current, I can take like this. Okay, Vx minus 8 by 470 plus 1000 plus what is the current through 1 kilo ohm? Again here it is Vx by 1 kilo ohm, which is a 1000 ohm resistor. It is equal to, these two are the outgoing currents and this is the incoming current. What is the incoming current? So incoming current is 2 amperes. So 2. This is one equation which one unknown, so that we can find the answer easily. Okay, so let me find answer. Take all the Vx terms to one side, constants to other side. So Vx common, if you take Vx common, you will get 1 by 1000 plus 470, 1470 plus 1 by 1000 is equal to 2 plus 8 by 1470. Now let me find Vx here, then RH here. Vx is equal to, what is the constant here, what is the coefficient of V1, that we need to find first. 1 by 1470 plus 1 by 1000. What is the value? So it is Vx multiplied with 247 by 147000. 147,000. It is equal to 2 plus 8 by 470. What is the value you can get here? 2.017. Okay, now Vx is equal to 147,000 into 2.017 divided by 247. Just I have cross multiplied with the LHS term. So 147,000 into 2.017 divided by 247. So what is the value we can get? We can get Vx as 1200.40 volts. But this is not VTH. How can I get VTH? First I need to know this current. After knowing this current, by adding this voltage with the drop here, I will get this voltage. Okay. So now what is the current through this path? Let me consider this as Ix. Okay, Ix, because I need Ix. So that's why this Vx Ix is equal to Vx 1200.40 minus 8. This voltage source value is 8 minus 8 divided by, what is the total resistance? 1470 ohms. Okay, now let me simplify it. 1200.40 minus 8 divided by 1470. So what you will get? 0.8111. 0.8115. Or let me do it up to 4 digits. Now what is this current? So this current is flowing from 1 kilo ohm resistance as well as 470 ohm resistance, because these two are connected in series as I opened this element. Now according to this current direction, give the polarities for this resistance. It is plus, it is minus. Now what is the current flowing? 0.811. Now for this small loop apply KCL. Apply KVL. You will get VTH value. Let me show how can we do it. So for this small loop, so the voltage source value is 8 volts and this resistance value is 470 ohms, and it is plus and this is minus. So this is plus and this is minus, and you need to find VTH value. So this is VTH. So this with plus sign, positive sign, this is VTH. Now when you apply KVL for this loop in any direction, what is the equation that you will get? Let me show. So it is minus to positive, so voltage rise, I am taking plus 8, minus to positive, so it is a plus into 470 into, what is the current flowing through that 470? 0.8111 plus to minus, so minus VTH is equal to 0. Now what is VTH value? VTH value is equal to 8 plus 470 into 0.811. So I am doing with the calculator. You need to do along with me, then only you can understand. So 389.217. So this is the VTH. Okay. Now we need to find RTH. RTH will do it in the next page because the space is not enough here. At the open circuited terminals, we need to find the resistance by removing the voltage source and current source. Deactivating the voltage source is nothing but making it into a short circuit. Deactivating the current source is nothing but making it into an open circuit. Let me draw. So this is 470 ohms. So this is 470 ohms. And here you have an open circuited path. And here, what is the resistance value? 1 kilo ohm resistance. And here 1 kilo ohm resistance. across this 1 kilo ohm resistance you have a current source which is parallel. When you are applying Thevenin's theorem, you need to make the current source as open circuit and the voltage source as a short circuit. Okay, so I'm making that voltage source as a short circuit. Now we need to find the resistance across these two terminals, and we can call that resistance as Thevenin resistance, because when you are applying Thevenin's theorem you need to find first VTH and then we need to find RTH, then we can find the current flowing through any element by connecting it as a load resistor. Now let me find RTH value. So when you see from these two terminals, these are the two terminals. Let me assume these two terminals as A and B. When you see these two terminals, this is one path and this is another path. These two are connected in series because it is disconnected here. So as these two are connected in series, what is the resistance? You will get 2 kilo ohm resistance. Okay, so 2 kilo ohm resistance. Let me draw this 2 kilo ohm resistance here and open circuited terminals. The series connection of 1 kilo ohm and another 1 kilo ohm is replaced with a single resistance of 2 kilo ohm. And what is the another resistor? 470 ohm resistor. So 470 ohm resistor. Now connect this to this. What is this terminal A? This terminal B. The voltage across these two terminals is RTH. Sorry, not RX. It is RTH. RTH means Thevenin resistance. Thevenin resistance. Now when you see from these two terminals, 470 ohms and 2 kilo ohms both are connected in parallel. That's why RTH is equal to, what is the formula for parallel resistances? R1 into R2 by R1 plus R2 in order to find the equivalent resistance when the resistors are connected in parallel. So 470 into 2000 divided by 470 plus 2000. It is equal to 470 into 2000. Let me find the RTH value divided by 470 plus 2000. It is a 380.56. So the RTH value is a 380.56 ohms. Now let me see VTH value. What is VTH value? We got here, it is there, 389.217 volts. So VTH value is 389.217 volts. Now we need to find I. What is I? The current flowing through that resistor, 100 ohm resistor. Now the load resistance is 100 ohms. Load resistance is 100 ohm. Therefore, how can you find IL? What is Thevenin's equivalent circuit? So this is VTH in series with the RTH connected across the load. So what is the load here? RL. Now it is a simple one loop circuit. In this loop, in order to find the current, what is the formula? IL, which is the load current, is equal to VTH by RTH plus RL. Okay. Now what is VTH? This one. RTH is this one. RL value is 100 ohms because we need to find the current flowing through this resistance. Now let me find the current. We need to check whether we are getting the same current or not. We found by using nodal analysis, we found by using mesh analysis. In this case, we are finding the current by using Thevenin's theorem. So VTH by RTH plus RL. Okay, I am taking the same notation as I is given in the problem. I am taking I as load current. What is VTH? 389.217 volts divided by, what is RTH value we got? 380.56 plus, what is RL we got? 100 ohms we got. This as RL. Now it is equal to, let me evaluate this value, 389.217 divided by, when you are doing the calculations, keeping the brackets is very, very important, as you have studied board mass rule in your childhood, means in your schools, we need to apply that Bodmer's rule to obtain the exact results. So what I got here is 0.8099. 0.8099. Now when you write it only up to 2 digits, I can write it as 0.80 amperes. Okay, so we got the same current now through the 100 ohm resistance by applying Thevenin's theorem. Next, by applying nodal analysis. Seriously, let me show the nodal analysis. With the help of nodal analysis, we got 0.8 amperes. With the help of loop analysis, we got 0.8 amperes. And we have applied Thevenin's theorem also, and we got the current as 0.8 amperes. So whatever method we are applying, we must get the same answer as the result. Okay, so I am stopping here up to Thevenin's theorem. We will see how to obtain the same value of current using the Norton's theorem and superposition theorem in the next video. So I hope this video helped you. If you have any doubts, genuine doubts, post them in the comment section so that if possible I will try to clear your doubts. If you really like this video, please hit a like button and share it to your friends so that it will be useful for them. Okay, so thank you very much.